Hi, and welcome to Group 2's video demonstration of a remote LED project. The ability to control elements of an IoT network and not actually patch into that network is critical, as it allows for the monitoring and control of these devices from absolutely anywhere in the world. On a very high level, our project works by interfacing the Arduino microcontroller to a Raspberry Pi server wirelessly using XBee. The server powers the front end and collects user input from the front end and passes these commands to the Arduino. It also fetches the status of LEDs from the Arduino, allowing us to view an up-to-date state of the system even if we change browsers or refresh the page. Keeping the web page updated with the most accurate state of the system is important to any IoT application. Typically, when refreshing a page or loading it on a different device, the variables which tell you if a light is on or off reset to their initial values, so you get an inaccurate representation of what's actually happening. Therefore, each time you open the page or refresh the page, it sends a query to the server, then to the Arduino, to send you an updated status of all the LEDs. This will make sure your page is showing correct information. In addition, if you change something on one page, it will dynamically update all other connected clients so that they don't have to refresh or load again. As you can see, we are now powering on the server. The server is opening and listening on port 3000. This is our web page. This is the LED system. Now, here you can see that we have received nothing from the server and sent the message indicating that no LEDs are turned on. Now we power on the first LED and power on the fourth LED. We then proceed to power off the fourth LED and the first LED. Our system is responsive to mobile and can be controlled from any phone. As you can see, you can control the LEDs from your phone as well as your computer. The system will update such that if you control something on your phone and you change something on your phone, it will be reflected on any other web pages that might be watching what's going on. When you refresh the page, you can see that the status of the LEDs remains on the page, on the computer, and on the phone. Here we can see a more in-depth look of the messages being sent and received from the server. We are essentially sending binary information as a 4-character string to indicate whether each one of the 4 of the LEDs is off. The message S represents a query to the Arduino to see what LEDs are on. If you get a message S, the website will update to reflect the most accurate information it has. Port forwarding and DDNS are critical to the functionality of this project. These are our credentials and the ports and IP addresses we use to interface the server with the outside world.